everybody. This is, I guess, the start of another unit, so like another little mini unit that, depending on the year, depending on how everything sort of falls, that we may or may not be able to fit in like a given year. So. And again, like something I would call like a mini unit, a little bit of a extra bonus unit that sometimes we're not able to do. So I'm going to call it Unit Y, kind of like how Unit X was with matrices. I'm going to call this Unit Y, and it's about conic sections. And what that sort of refers to is quite almost like literally a cross section of a cone or a couple of cones like this. So there's four major ones. So if you have something slicing a cone like this, the cross section actually makes what we know to be a parabola. So we already know about parabolas, and obviously you know about circles, but that's also included in this whole conic section thing. If the cross section was basically parallel with the base of a cone, the cross section would be a perfect circle. And that's what we're going to be looking at today a little bit with certain things, parabolas and circles, and then in later sections we'll talk about these things called ellipses, which is essentially an oval, and so kind of a slanted slice right here, and then these things called hyperbolas, when you have a slice like that through like both of those cones there. So let's get that out of the way. And so today we're gonna, like I said, we're gonna tackle parabolas and circles in what I'm gonna call, section Y.1. So I mean, and again, the good news is you've already seen parabolas before, probably in your Algebra 2 class. So I don't know how fuzzy you are remembering all that stuff, but let's kind of review a little bit of it. And so a parabola, like an equation that represents a function that gets graphed as a parabola, here is what you were shown to be vertex form. So if an equation is written like that, where x is still just x, y is still just y, but we have some a value, some h value, and some k value, and it kind of fits that mold, it's in vertex form. Okay? And the convenient thing about this form is that h comma k is the what? It's the vertex. This value right here would be the x coordinate of your vertex, and this value right here would be the y coordinate of your vertex. So did I say that right? X coordinate right here, h is like literally your x coordinate, and k is your y coordinate. And this a value, would be like the stretch factor. More specifically, I guess, your vertical stretch factor, when you compare it back to like just the plain as can be, just y equals x squared. Y equals x squared has a certain graph. It has a certain like basic shape. It's like the most basic parabola you can have, right? It's in fact it's called, remember, if you call it, that we call it the parent function, you know. And so here your a value is basically 1. But if you have some other a value, it vertically stretches it, or even you could say it condenses it, depending on your a value. But and also it flips the parabola if a is negative. Trying to conserve space here. Okay? So if your a value is negative, that means your parabola is going to be upside down. And I guess we'll see how that sort of plays out in the examples. But maybe you recall that there was also standard form. Okay, standard form of a of an equation that represents a parabola. You know what I mean? And like this a, b, and c. I mean, funny enough, this a value is going to be exactly the same a value that would have been there if it would have been given in vertex form. But like right on its face, you know, this b value and this c value don't really mean anything directly in the graph. It's not like looking at this vertex form and going, oh, that's my x coordinate of my vertex, and that. I mean, these b value and c value, like, they do mean something, and it's basically this. I don't know if you recall this thing called the axis of symmetry. The axis of symmetry sort of means what it kind of sounds like, you know, axis of symmetry. Parabolas are symmetrical, and the axis of symmetry would be like the vertical line that pretty much cuts the parabola in half. You know, it's a vertical line that goes right through the vertex of your parabola. And when you're given an equation in standard form, then you go ahead and you find this axis of symmetry by using that little mini formula. X equals negative b over 2a. Okay, and that is going to get you your axis of symmetry, you know, which again is just kind of like a vertical line. If the axis of symmetry ends up being like x equals 4, you know, remember, x equals 4 represents a vertical line, like as an equation. So having this x equals here as part of it is pretty much technically necessary. Now over here, for a little comparison quick, finding the axis of symmetry, well, I mean, you don't really have to go like too deep into this, and you don't need a formula to figure out the axis of symmetry over here. Isn't it just going to be like x equals h? You know, like if your vertex, for example, if your vertex ends up being like 3, negative 5, you know, which you get very quickly from the equation. So if your vertex is like 3, negative 5, well, wouldn't that just make the axis of symmetry x equals 3? It's going right through the vertex, and like that's what x equals with the vertex. So yeah, but so here you don't need some little formula to do it. But if you're given standard form, then yeah, you need that x equals negative b over 2a, and that pretty much like gets you on your way to drawing your graph. But let's see that in action. Here we go. Couple examples. Graph the following parabolas. So I'm actually going to go all the way and graph these, I guess, but if we're working with distance learning, which I know we are here in like 2020, you know, you may or may not be able to actually give me the final graph. You might just have to, or be able to describe it, or, you know, tell me what the axis of symmetry is, and what the vertex is, and maybe, like, you know, you'll see, I guess, in your homework assignment, like what am I gonna, you know, what I'm gonna ask you to do, but it might not be actually drawing the final graph. You know what I'm saying? So here we go. Example number 1: y equals, and then we have x minus 2 squared, and then minus 7. Well, I hope there's not that many cobwebs keeping you from, like, realizing that this matches vertex form. Okay? Just kind of turns out that A equals 1 because there's like a 1 out in front. My H is 2. Not negative 2, just 2. Something I might find myself repeating a few times here is that there's a negative built in to the form. You know, this doesn't say x plus h, it says x minus h, you know. And here it's a plus, so you know, you'll see how that plays out, but there's a negative built in there. So it's x minus and then h. So h here is just 2. Now here we have a minus 7 at the end, so k is actually negative 7. Because the form says plus k at the end. So, like, okay, so if I wanted you to, like, tell me now the axis of symmetry, you know, you could just say x equals 2. Okay? Because what's the vertex? And why is my board acting up right now? Like, what's my vertex? Isn't my vertex literally h comma k? So my vertex is 2 comma negative 7. So I can go over here if I'm actually, if you're actually graphing this, 2 comma negative 7. There's my vertex of my parabola. Like right there in the equation, right in front of your face. So yeah, doesn't it make sense that the axis of symmetry would be x equals 2? Now, to draw the rest of my parabola, here's what I'm going to probably lean towards, like, emphasizing. Because there's multiple ways to sketch your parabola now and make it fairly accurate, like a decent sketch. You know, I don't need an amazing sketch, but there's a couple different ways to do this. I guess for right now, I will focus on just plugging in something else. Okay, just plug in something else that will get you another point or two. Okay, now hopefully you pick something that's going to turn out nice. You know, like you could plug in 0. Here, I would actually recommend plugging in 2. And let's see where that gets us, you know. So hopefully you pick something where you wind up with something relatively close to the origin. You know what I mean? Like if you picked x equals 10, okay, and you did 10 minus 2 to get you an 8, and then you did 8 squared, that's 64. And then you do like 64 minus 7, you're going to get a point that's like not necessarily in this nice close to the origin sort of inbounds graph. You know what I mean? So, you know, you might end up picking something that you regret, but Here, I'm actually going to pick x equals 2. Actually, no, I'm not, because if I pick x equals 2, I'm going to just get the vertex, right? So let's just pick 0. That's probably the most common value anyway. So if I pick 0, okay, and I literally like let x be 0, that's going to be 0 minus 2, which is negative 2. And then when you square negative 2, you get a positive 4. And then, so positive 4 minus 7, that means overall y is going to be negative 3. So when x equals 0, apparently y equals negative 3. So literally 0 comma negative 3, that's another point on my graph. So again, let's just plug in 0, you know, as like to just generate like another random point. You know what I mean? So again, plugging in 0 for x, I end up with overall y equaling negative 3. So that means there's another dot on my graph, okay? Which does make sense, because if my a value was positive, my parabola is going to just stay right side up and not be flipped upside down, correct? Now to get another point, I could plug in something else, but what you probably want to do is take advantage of the fact that parabolas are symmetrical, and if that's a dot, and if that's the vertex, and if this is the axis of symmetry, if I just kind of mirror and reflect this point and find like its corresponding partner point, like on the other side of the axis of symmetry, wouldn't that just be right there? And so another point would be 4 comma negative 3. 4 comma negative 3. And so, you know, I can sketch my graph. You know what parabolas look like. And so whether or not you can actually sketch it on your assignment, at the very least, you can tell me things like, what is the vertex? What are like 2 other points? You know, maybe what's the axis of symmetry? I don't even want to go into like maxes or mins. I mean, this has a minimum value. I mean, maybe I can ask you if the parabola is like upside down or not, but I don't know. I guess that's fair game, right? You shouldn't be scared of me asking, hey, does this function have a maximum value or a minimum value? Because parabolas either have minimum values, or if it's upside down, it would have a maximum. So this has a minimum of negative 7. Because its lowest y coordinate, its low value is negative 7, like the y coordinate of your vertex. Let's move on. Let's do this next one. Hopefully this goes a lot quicker. You know. So looking here, okay, it looks like here this is also in vertex form, yay. And so my a value is going to be negative 2, which is going to mean a upside down parabola. My h value is right here. It's actually negative 1. And my k value, well, wouldn't that be right here, plus something? Well, there wasn't a plus something. So wouldn't it be like kind of an invisible plus 0? So my k value is 0. So so that just means my vertex is again literally h comma k, so negative 1 comma 0. So right there, if I was actually drawing the graph. And that means that my axis of symmetry, you could just say really quick, is x equals negative 1. You know? And if I wanted to come up with two other points, I could just plug in something, you know, random, but maybe not that random. Like what if I plugged in 0? Okay, so another point would be 0, comma, something. So if I plug in 0 for x, it's going to be 0 plus 1 to be 1. 1 squared is 1 times negative 2 is negative 2. Remember, follow your order of operations, peoples. You would do the adding, and then the squaring, the power, and then times the negative 2. So let's just double check. 0 plus 1 is 1. 1 squared is 1 times, okay. So 0 comma negative 2 is another dot, okay? And if this is the axis of symmetry, then another point on the other side of that would be, it looks like negative 2 comma negative 2. And that does check out because we already said a couple minutes ago that because we had a negative a value, my parabola was destined to be upside down. And so this one would have a maximum value now because it's got an absolute highest value of what? What's its high value? It would be 0. Okay, a high value, a maximum value of 0. Now, this maximum value happens at x equals negative 1, at x equals negative 1, but the actual maximum value is a y-coordinate, so it's 0. Couple more examples, okay? These ones, spoiler alert, are actually now given to you in standard form. Standard form. So here's what we have to do. We have to use that special formula to find the axis of symmetry. So here, it goes ax squared plus bx plus c. So my a value is actually negative 1. Hey, that means it's going to be upside down. My b value is 6, and my c value is 5. So now I can do my axis of symmetry. That's going to be negative 6 over 2 times negative 1. Okay? And so so this is a negative 2 down here. So basically negative, we'll just say it's negative 6 divided by negative 2. So that should be 3. So my axis of symmetry is actually x equals 3. So I can already sort of sketch that. So my vertex is going to be like somewhere on there. In other words, my vertex is going to be 3 comma something. So what is that something? Well, guess what? It's as easy as taking the 3, taking your x coordinate, and just plugging it in to the original equation and seeing what y is if x equals 3. So you take this axis of symmetry, x equals 3, plug it into the original, and so this is going to be negative 3 squared. And so, okay, I'm only squaring the 3, not negative 3 here. The negative is out in front, and then it's 3 squared. So this is going to be negative 9, not positive 9. Negative and then 9. So negative 9 plus 18. That gets me positive 9 plus 5. So that's going to be, so negative 18, wait a minute, negative 9 plus 18 is 9 plus 5 is 14. So, wow, I'm definitely going to be struggling to graph that here. But I can at least say, okay, that's my vertex. All right. And then as far as like what else I might require of you, well, let's get another couple of points. Like let's plug in 0, which is random but not so random. And this is going to be beautiful because if I plug in 0, 0 squared is gone. 6 times 0, that's also gone. And what you're left with is 5. So 0, comma 5. Okay? 0, comma 5. So that's another point, and to get like yet another point, I can just kind of reflect that. And so this point would be 6, comma 5, so that should be another point you can specify. So axis of symmetry, the vertex, a couple other points, and this one would have a maximum of what? 14. Another example, well, again, standard form. So we start with our axis of symmetry, which is negative b, which is negative 4, over 2 times a. A is 1/2. So 2 times 1/2. So negative, negative, that's overall positive. So this is like 4 over 1. So that should just be 4, right? 2 times 1/2 is 1. Positive 4. So I already know that my vertex is going to be 4, comma something. So how do I figure out the other coordinate of my vertex? Like, how do I figure out that if x is 4, what does y have to be? Plug it back into the original. 4 squared, remember, order of operations, peoples. 4 squared is 16. Then times 1/2 gets you 8. This is going to be a minus 16. So 8 minus 16 is negative 8, and then the plus 7. So I do believe it's a dangerous business doing this in my head. Let me double check this. 4 squared is 16 times 1/2 is 8. So I'll just e. And then minus 4 times 4 is 16. So 8 minus 16 is negative 8 plus, okay. So negative 1. So 4 comma negative 1 right there. So there's my vertex. Now again, let's just, to get another couple of points, let's just plug in 0, because 0, again, this term is gone. 0 squared is 0. Times 1/2, still 0. Minus, basically, that's gone. 4 times 0 is 0. So basically, plus 7, and so y just equals 7. So 0, comma 7 is another point. That helps you sketch your graph. And then just kind of go to the other, like reflect that. So boom, 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 boom. So like right there. And so it looks like 8, comma 7 would be another point on your graph. And then it would have a minimum of negative 1. Absolute lowest value of, and all you got to do is look at the y coordinate of your vertex, minimum of negative 1. Woo! Okay. I don't know how long we're into this video, but that was just Algebra 2 flashback. Now we're going to look at circles. Now the other, I mean, there might be some good news here. I know in the year 2020 here, I have mentioned standard form of a circle before. So there's actually equations that get graphed as circles. And so here it is. We got so that's what that looks like. Okay? And what that means is we have H and K, which together, It's not going to be the vertex this time. I mean, remember, people, this is a circle. These are circles, not parabolas. So h comma k is going to be the center of the circle. And we also have an r value, which you've probably already guessed, is going to be the radius of your circle. So again, we have like, if your equation fits this mold, fits this form, then all you got to do is look at the h value and the k value. That'll make your center. And then the r value, which is going to be your radius. And you can graph it easy peasy. So let's do a few examples. I think 5. All right. Now, really good news. Both of these examples you see here to start us out here, they are actually both in standard form, right? X minus something, quantity squared, and then y minus something, quantity squared. Well, here, isn't this essentially x minus nothing squared? And then this is like also y minus nothing, y minus 0 squared. And so my h value is technically 0. My k value is technically 0, which is going to have us have a center of 0, 0, which I probably shouldn't actually, I shouldn't actually draw that. Like, that's not going to actually be in like the final graph. But yes, 0, 0 is going to be our center, you know. And if r squared is 16, well, that just means that r is 4. So here's the center, which you're not actually going to like graph it. You know, maybe I can just, maybe I'll use, you know, kind of a lighter shade, but so it's going to be bam, and then I'm just going to do. I mean, but this makes a whole, all right? So it's a circle that has a center of 0, 0 and a radius of 4. How easy was that? Number 2, it's also pretty easy. Look, already in standard form, you can call it. And so your h, what's h? Remember, there's negatives built in to the form. So wouldn't this make h just 1? And wouldn't that make k actually a negative 2? Yes, it would. And so my center is 1 comma, oopsies, 1 comma negative 2. And then the only other thing we need here is the radius, and if r squared is 25, that means r is 5. So from the center, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I can then sketch my circle. Okay? How easy is that for standard form? Number 3, another one that's in standard form, right? So what is h? Well, h is just 3. What is k? K is 0. So that makes my center 3 comma 0. And if r squared is 10, that makes r the square root of 10. Okay? What the heck is the square root of 10? Well, I know it's going to be 3 point something, because 3 squared is 9 and 4 squared is 16. So it's like, you know, what's the? I mean, we don't even need to go like super exact here, but might as well go to a calculator and see if I can hit the right buttons. So that's about 3.2, you know. So 1, 2, 3, just see, we don't need to be that exact. I mean, 1, 2, 3.2, 1, 2, 3.2, 1, 2, 3.2. Because we're just making sketches. Now, okay, let's pick it up a notch with number 4. Number 4, if you notice, is not written in this nice standard form where you have like a bubble squared and a bubble squared, or even if it was just y squared, that would still sort of fit because it'd be like technically y minus 0 squared. But this, oh man. Well, again, it is very possible, I know I did it here in 2020, that I've already taught you about this, or not officially, like maybe for a bonus opportunity or something, but I've already talked about this probably, you know what I mean? Where, okay, x squared, like I'm good, okay? X squared is fine, but this 8y, you know what I mean? What if I were to like, it's called, long story short, okay, let's cut to the chase. It's called completing the square, you know? If I thought of like y squared plus 8y being like its own little grouping, and if I could throw something else in there that would make it a perfect square trinomial, meaning, here's what it means, that you could unfoil it into the same bubble twice. Okay? So what would be this magic third term that would allow you to unfoil it into like the same bubble twice? Well, here's the shortcut. Cut that 8 in half and then square it. So half of 8 is 4. When you square it, it's 16. So we're going to actually just toss in there a plus 16. Now, we can't just do that. We also have to, you know, keep things balanced. We'd also have to like add 16 to the other side, you know? So that now updates this into y squared plus 8y, idiot. Whoa. Jeez. That was almost a disaster. But then, man, focus. Equals negative 7 plus 16. That should be a 9. Now, why, again, like I already mentioned this, but I hope you understand why this is like going to totally get us where we want to go. This unfoils into y plus 4 times y plus 4. In other words, y plus 4 squared. And now, you see how now this matches vertex form, not vertex form, idiot, standard form? Exactly. You know? And now we can look at this and go, oh, h is 0, k is actually negative 4. So 0 comma negative 4 is my center. My radius, since that's r squared, my radius is 3. So 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, just sort of, oh God, oh, that's awful. Oh, well, what are you going to do? So that's how that cookie crumbles. Last example. Oh, another one where it is not even close to being in standard form. So what we're going to have to do is we got that minus 4x term there and the plus 3y. So we're actually going to have to complete a couple squares. Again, this is called completing the square. So how could I finish off this? Like x squared minus 4x plus what would be like perfect, where you could like unfoil it into like a bubble squared. Remember, the shortcut is cut this in half and then square it. So this would be like a negative 2, but when you square it, it's positive 4. Now again, we also have to, like we can't just do that. It's illegal just to do that, unless of course you're also adding it to the other side. You know what I mean? Like nullifying what you just did. Okay, how about this? What about this? Let's complete this square. So again, half of this is 1.5. And then when you square that, I believe you get 2.25. So again, we also have to do that over here. So wow, okay. So x squared minus 4x plus 4 plus y squared plus 3y plus 2.25 equals, oh boy, that should just be 1. Okay? Now, this now unfoils into x minus 2 times x minus 2. So x minus 2 squared. And this would unfoil. I know this is like really weird, unfoil. I'll address that in a second. But like y plus 1.5 squared. I know, again. This is really just for the sake of graphing it, because it turns out that the center of the circle is, here we go, right? Positive 2, because there's a negative built in. And here, k is negative 1.5. So 2 comma 1.5, which is right there. And, okay, what's my radius? If that's r squared, well, then I guess my radius would still just be, oh my gosh, this is going to be like a tiny circle. Right there, right there. Oh my gosh. So that does it for the graph. You know, the circle is 2 comma negative 1.5. The radius is 1. And again, I know that's really weird. So here's what I'll say about that. This is not like really necessary to understand right now or know right now, but just saying, what that probably means is like this original equation probably wouldn't have been presented that way. You know, like maybe we could have like multiplied everything by 4. Because if you multiply everything by 4, like this becomes a really nice integer. And over here, this stuff just becomes what it's going to become, you know, 4x squared. So again, it's not a step that you need to be aware of. It's just that, I mean, look, you know, we ended up with like this nasty sort of unfoil just because that we had to. But I guess all that meant was like, I guess you shouldn't be surprised if we would have been given the original equation like a different way, but whatever. And so that sort of covers a little bit on parabolas and circles and their standard forms.